Hey, everybody. We are in the Tennessee Revealed Geometry and brand new unit, lesson 6-1. All right, we're on perpendicular bisectors. Now, we have, in my class at least, talked about this before. Perpendicular means you are looking at a 90-degree angle. Bisector means it has cut something in half. In this particular one, it's going to be you're cutting a segment into two congruent parts. All right, so perpendicular bisector, there you go. All right, looks like we're going to talk about concurrent lines, point of concurrency in the circumcenter. So, okay, that's what you get when you put your perpendicular bisectors on a triangle and they all meet at one location. So I'm sure we're going to be looking at that in depth. Okay, so this is what you need to know, nitty gritty. You're looking at a triangle where you have a 90-degree angle because you have a line, a segment, a ray, something is cutting through to form that 90-degree angle and cutting a segment like this, AB, in half, two congruent segments. All right, that means AC is also congruent to CB. So you're looking at basically side, side, side. You're looking at two triangles where the three sides of one triangle and the three sides of the other are the exact same. So SSS for side, side, side. All right, let's just get into it. Example number 1. So I'm in your book on page 349. I've got the textbook open, the student version, and let's see what we got here. We got to find EF. Now, EF is one of the sides, and namely the hypotenuse of this right triangle, and they are wanting us to find that. That means I got to find A, and I got to do some plugging and chugging. Well, if this hypotenuse EF and this hypotenuse AFH are equal to each other, you're going to set them equal. So 4A minus 15 equals A plus 12. Why? Oh, come on. All right, fine. A plus 12. All right. So I don't particularly like that it makes us solve all in one, but okay, so subtract A to the other side, add the 15 to the other side. Tell you what, I'm going to do it for my visual people, or my teacher notes are on. Make it easier for my visual people. All right, so 4A minus 15 equals A plus 12. All right, so listen, I'm going to subtract A to the other side. So 4A minus A is 3A. Bring down my minus 15 and equals 12. Now I'm going to add 15 to the other side. So plus 15 to the 12. So that's going to be 3A equals 27. Because 12 plus 15 is 27. And the opposite of multiplying by 3 is to divide by 3. So 27 divided by 3, that's going to be 9. So A is going to be 9, visual people. All right, so now we're going to do a little plugging and chugging. I'm going to take that A out and replace it with 9. So 4 times 9 minus 15. Well, 4 times 9 is 36. Minus 15 is 21. So the length from E to F is 21, which means the length from H to F is also 21. All right, looks like I've got a check here. Okay, so same thing. I'm looking for RT, and this hypotenuse QR and the hypotenuse TR are going to be equal to each other. So for my visual people, I'll open this up. 2x plus 3 equals 4x minus 7. All right, I'm going to subtract 2x to the other side. So we've got 3 equals, well, 4x minus 2x is 2x. Don't forget your minus 7. All right, the opposite of subtracting 7 is to add 7 to the other side. So 3 plus 7 is 10, and that's going to equal 2x. And of course, the opposite of multiplying by 2 is to divide by 2. 10 divided by 2 is 5. So our x is going to be equal to 5, everybody. Now, this is not our final answer because we have to plug and chug. So I'm going to take that x and replace it with 5. 4 times 5 is 20, and then 20 minus 7 is 13. So our final answer is 13, everybody. All right, so we got a couple of extra examples online if you want to go there. I'm just going to go on to example number 2. All right, we need to find x, y. All right, so here's x, y. Okay, well, I've already said it, but I'll say it again. This is basically two triangles that are congruent by the three sides that they have. 25.3 will be equal to 25.3. WY will be equal to itself, WY, which means that ZY and XY are equal to each other. So that's an easy problem. It's going to be 22.4 because it's been bisected. So 1/2 will be equal to the other half, 22.4. Nothing really solved there. All right, got a check. If you haven't realized, I've turned to page 350 and we're doing the check right below example number 2. WY, all right, got another easy problem. It's going to be 3 because ZY is 3, WY automatically 3. All right, got another couple of examples online if you want to check that out. I'm just going to mosey on down to the bottom of the page where we see the definitions of concurrent, point of concurrency, and circumcenter. Okay, so let's go through what all this is. When you have 3 lines that intersect at one point, these are called concurrent lines. It doesn't matter if it comes from perpendicular bisectors or medians or angle bisectors. If you have 3, well, or more, you can have 4 lines that intersect at one point. They're called concurrent lines. The actual point where they meet each other is the point of concurrency. Now, for perpendicular bisectors, angle bisectors, and medians, they all have a different name of that point of concurrency. So for perpendicular bisectors, the point of concurrency's specific name is the circumcenter. Now, circum means around. So you probably have heard things like, area and circumference. So circumference, the circum in the circumference is around the circle. Okay, so let's get into example number 3. All right, so looks like we got several things going on. We got to find BF. For you visual people, there's B, there's F. I'm looking for that distance. All right, but it says D is the circumcenter of triangle ABC. AC is 9. All right, remember, it's been bisected, so from A to C is 9. You would divide 9 by 2 to find AE and find CE. All right, then it says DE, which is the perpendicular bisector, is 1.83. DF, another perpendicular bisector, is 1.53. All right. So let's see what we got here. It says D is the circumcenter of triangle ABC, so that DE, DF, and DG are perpendicular bisectors of the triangle. Okay, because DE bisects AC, then EC is half of AC. Okay, well, I said that a minute ago. I said you're going to take 9 and divide by 2. So 9 divided by 2 is going to be, don't worry, it's going to be a decimal, be 4.5. So that means AE is 4.5 and CE is also 4.5 or 4.5 if that's what suits your fancy. All right, so now it looks like we're going to do the Pythagorean theorem to find DC because we have DE in the directions it said is 1.83. We now have EC thanks to our taking 9 and dividing by 2, which means we have 2 sides of a right triangle. And we're looking to find the hypotenuse, DC. So we're going to do a squared plus b squared equals c squared. And it looks like they already set it up for us, which is super nice. So I'm just going to finish out 3.35 plus 20.25 is 23.6. And the opposite of squaring is to square root that 23.6. And it looks like it's approximately, I'm not sure what they want us to round to. You know what? I'm going to round to the nearest hundredth because that's what they did in the problem. So I'm going to put 2 decimal places. So approximately 4.8. And the 7 is going to make the 5 go to a 6. All right. So we're going to go with 4.86. All right. Can't be negative, so we have to go with the positive answer. All right, so what did we actually just find? We found DC, we found BD, and we found AD. We actually found all three of those because remember, D is the circumcenter, which just means it's centered into the circle. So it's equidistant from DC, DB, and DA. So we just found all three of those actually, 4.86. All right. All right, so let's see. Now what we're going to do, we're going to mosey on over to actually what we've been looking for. We've been looking for BF. Don't forget that. So I'm going to mosey on over. Well, okay. So now that I've got DC, I actually have DB as well. And in the problem, they gave me the length of DF. So now I have two sides of a right triangle. But this time I have the hypotenuse and I have one of the legs. Still going to use the Pythagorean theorem, but instead of adding the two terms, because we have our hypotenuse, we're going to end up subtracting to the other side. So I'm going to go ahead and square 1.53, and that's going to be 2.3409, and I'm going to square the 4.86. If I can hit the right buttons on my calculator. All right, so that's 23.6196. All right, we're going to subtract that 2.3409 to the other side. So I'm going to calculate, I'm subtracting 2.3409 and end up with 21.2787. And the opposite of squaring, it's a square root that number. All right, so I am looking at 4. I'm going to round to the 100th because that's what they're doing in the entire problem. So it's going to be 4.61 because the 2 that's after that 1 is not going to make a change. So BF is about 4.61, everybody. All right. Okay, so by the way, that's BF and it's also CF. Okay. Moving on. Oh, so we got to check. I'm on page 351 at the bottom. We got to check here. All right, we got to find SV if S is the circumcenter. Okay, so we're looking for SV right here. QR is 7.79, so I need to divide that by 2 to find what QV and RVR. Okay, it says that PS is 4.25. Well, that means that QS is also 4.25 and SR also 4.25. So it looks like we're going to do the Pythagorean theorem again, everybody. All right, so let's see what we have here. We need to find SV, which is this little bitty perpendicular bisector from the circumcenter out to V, which is the bisector. V is in the middle. So I'm going to take 7.79 and divide by 2. All right, so from V to R, I just found is 3.895. 3.895. And I know that SR is 4.25. So I'm going to set up a Pythagorean theorem with SV squared plus 3.895 squared equals my hypotenuse 4.25 squared. All right, so here we go. SV squared is not going to, I'm going to have to do it this way. SV squared plus 3.895 squared equals, in our hypotenuse, 4.25 squared. All right, so I need to square those numbers. Or you can just simply subtract 3.895 squared to the other side. I think that might be simpler. So I've got SV squared. The opposite of adding is to subtract to the other side. I'll let my calculator do the nasty work. So 4.25 squared minus 3.895 squared is 2.891475. So I did that on my calculator. Now the opposite of squaring is a square root. So I'm going to SV squared, square rooted, just leaves SV. And I'm going to square root the 2.89, yada, yada, yada. And it looks like my SV final answer. And I'm going to round to the 100th because that's what they've been doing, is 1.70. All right, so SV, everybody, 1.70. Okay, example number 4. Looks like I'm moving to the next page of your workbook, page 352. All right, it says Alonzo wants to install a fountain in his triangular garden. Where should Alonzo place the fountain so it's equidistant from the vertices of the garden? That means I'm looking at the circumcenter. That's where the 3 perpendicular bisectors intersect. All right, so let's see, circumcenters equidistant. So here's the answer to actually give it to us. So I'll tell you what I'm going to do. I am going to pull up my GeoGebra. I am going to plot these 3 ordered pairs. And I'm going to show you guys how to find the circumcenter of the 3 perpendicular bisectors, just to prove that this is the correct answer. All right, so here are my 3 ordered pairs, 0, 12, 8, 2, and negative 8, 2. All right, here we go. All right, so I'll move this so that I can get all my ordered pairs in. So I need a 0, 12, I need 8, 2, and a negative 8, 2. All right, so I'm ready to go. I'm going to click on Polygon, 0, 12, 8, 2, negative 8, 2, and back to 0, 12. All right, and again, I'm trying to prove that the circumcenter is the answer in the book 0, 3.8. So I'm going to show you guys how to do 3 perpendicular bisectors. It's the 4th icon from the left. It's the one that looks like a segment that's blue and split by a red line. 4th one. All right, so I want the 3rd one down, perpendicular bisector. So I'm going to click on line A, which again is the side across from angle A. I'm going to click on side B, which is the side across from angle B, and side C, which is the side across from angle C. So there's my perpendicular bisector. Now I need to actually see what this dot right here is, what the point is. So I'm going to come over to point. I'm going to put a point right there. And yep, the book is correct. So it looks like 0, 3.8 is the place where he was going to want to put, what was it, a fountain? He's going to put the fountain right there. All right, so the book is correct. 0, 3.8, correct answer. And we have a check right below that. Yeah, so I'm going to do the exact same thing. I'm going to put my vertices at 2, 1, 7, 10, and 12, 1. So I'm going to clear this out. Boom, 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 boom. All right. So I need to move this so it looks like I'm going as high as 12. No, as high as 10 and as wide as 12. All right. Go to Polygon. All right. First one is at 2, 1. Boop. 7, 10. And 12, 1. And back to the first. All right, 3 perpendicular bisectors. So again, 4th icon from the left, 3rd one down. I'm going to click on side A, side B, side C. There's my point of concurrency. For perpendicular bisectors, we call that the circumcenter. I need a point there where they intersect. Boop, there it is. Looks like my answer is going to be 7, 4.11. 7, 4.11. Now, it looks like it says round to the nearest whole number. Okay, whatever. So let's see. 7, 4.11 is the correct answer. If they want us to round to the nearest whole number, then yeah, so I guess that'd be what? 7, 4. 7, 4. All right. Oh, I'll get another one. So, correct answer, rounded answer. All right. So, first one's the correct answer, second one's the rounded answer. All right. So, okay, there's another online example if you want to go on. Okay, practice is coming up on the next page. I am leaving you right here with this. You guys have a question? Let me know. Ask your teacher. Ask me. Happy to help. You guys have a great one.